Good morning, good afternoon, and good evening, based on where you may be coming in from. It's my pleasure to welcome you all to this webinar from GitaCloud. This is Puru Goyal. I'm a data scientist and IBP consultant with GitaCloud. I'll be moderating this webinar today. We all know the topic, Tactical Time Series, Supply Planning with SAP IBP. We will focus on cost-based optimization and differentiate it from the prevalent rules-based planning practices most customers have today to support their S&OP process. At GitaCloud, we focus on the hard business value from these next generation digital supply chain solutions like SAP IBP. For example, on a recent CPG pilot, we were able to cut forecast error for a key international market of a multinational CPG company by more than 500% using such advanced statistical forecasting capabilities in SAP IBP. Just before we start, a couple housekeeping items before we jump in. You can send us your questions anytime during the webinar. Use the GoToWebinar chat section to ask a question. We will consolidate all the questions and attempt to answer them all towards the end of the webinar. We will also follow up with you one-on-one after the webinar if in case we run out of time. All attendees' microphones will stay muted for the entire webinar. This webinar is being recorded and the recording will be available later on our website. Let me quickly introduce the speaker panel for this webinar today. Ashutosh Bansal is the founder and CEO of GitaCloud. Ashutosh has spent his career in leadership roles at PwC, IBM, and SAP prior to starting GitaCloud. Ashutosh helped sell and deliver multiple IBP customer engagements in his role as high-tech industry leader at SAP. GitaCloud started in March 2015 and has quickly scaled to have a global footprint and has become a close partner of SAP. Ashutosh also is an avid blogger and networker with close to 8,000 connections on LinkedIn. It's my absolute pleasure to introduce Jay Foster, who is the solution owner of IBP S&OP at SAP. Jay himself is an SAP SCM specialist and has played senior vice president, C-level leadership roles across sales, IT, and operations prior to joining SAP. Welcome, Jay. We also have Ashish Mishra, who is a managing consultant with GitaCloud India. Ashish has 11 years of SCM experience across several large customers in Europe and Asia. Ashish spent the last year at SAP Labs in Bangalore building multiple IBP demos for customers. He is hands-on expert in all IBP applications and has led multiple customer engagements for GitaCloud and also the leader for GitaCloud IBP Managed Learning Program. Let me review the flow of this webinar with you so you understand how we plan to spend the next hour. Ashutosh will cover the business context in terms of performance patterns by industry and drill down on the chemical industry as an example of the business complexity requiring IBP solutions powered by cost-based optimization with the on-fly what-if simulations as well. Next, Jay will cover an overview of SAP IBP for response and supply. Jay will also provide an update on the adoption of IBP response and supply application by industry. Next, Ashish will showcase supply optimizer capabilities and contrast the business value versus supply heuristic capabilities, so you have a first-hand appreciation of the financial benefits of such cost-based optimization within the SAP IBP platform. In the wrap-up section, Ashutosh will present how you can qualify if you have a problem that merits optimized-based solutions. Then I'll open the floor for our panelists to take questions from you. With that, let's jump right in. Ashutosh, over to you.
Thank you, Puru. Thanks everyone for joining. We understand how busy your schedule is, so thanks for making time for this webinar. Let's jump right in. So if you know Laura Ciceri and her team at Supply Chain Insights, they provide an annual list of supply chains to admire. So you can see the wheel of finalists outside and winners in the inner circle. What's striking is the small proportion of process companies as opposed to discrete. And trends are not good. When you go from 2016 to 2017, the pie, which is for the process industry, is shrinking further and further. And when we talk about process industries like oil and gas, chemical, pharmaceutical, consumer non-durables, you can see players like BASF, Clorox, Steroil. They were there in the list on the left in 2016, but they've lost their place in 2017. The question we are asking is, why is this so? With the rise in global complexity, process industry's focus has remained on traditional inside-out processes. They have been seeking efficiency still in functional silos, and they've largely failed to deliver supply chain excellence that comes with outside-in demand sensing, demand-driven process. This is in sharp contrast to when you look at consumer electronics, high-tech, semiconductor, which has embraced these outside and demand-driven processes. And the proof of the pudding is how many high-tech semiconductor names you see in that 2017 list on the right: Qualcomm, TSMC, Cisco, Apple, Broadcom, and so on. So what we wanted to do is just go through chemical industry, polymer manufacturers as example, and paint a picture of complexity that the chemical industry is dealing with, and that requires advanced solutions, and where things are lacking currently. Polymers, as you may know, are principally used to make plastic goods, constitute about 80% of chemical industry's production output. Polymers are used by industry, so you look at aerospace, automotive, electronic equipment, and also general public, right? All the milk and shampoo we buy, the bottles are all polymers. Now, in our assessment, most polymer manufacturers do not appear to have a very strong handle on planning across functions, and largely are lacking an understanding of how to optimize supply chain costs within functions as well. So when you look at the competitive landscape for the polymer sector, these are largely manufacturers that are selling to other customers that turn the polymer into plastic products. Those people then sell it to consumer product goods companies, and that in turn gets sold to retailers and then to consumers. So there are 4 or 5 tiers away from the final consumer and demand signal. Their product, polymer, is considered a commodity, and technical quality of the product is just a market qualifier. So the principal order winner is price. Polymers are made to stock, and delivery is expected to be instantaneous, while the manufacturing lead times and the transit lead times are not. So there's need for inventory. Also, there's been extensive mergers and consolidations within this industry. So what you have is a handful of companies supplying 80% of the global output of polymers. You look at companies in North America like Dow Chemical, LyondellBasell, ExxonMobil, companies in Western Europe like BASF or ENI, Middle East like SABIC, and in Asia like Reliance or LG Chemicals in Korea. The revenue for these companies ranging anywhere from $15 billion to $240 billion. Given the size and strength of these companies, the market for polymers is extremely competitive. Let's take a look at the supply chains for polymer. Raw material for polymers, often referred to as feedstock. This is byproduct of petroleum or natural gas production. Suppliers typically belong to the same group of companies as the polymer manufacturers do, and they determine the feedstock price in sync with the crude oil price. And the crude oil pricing, as you know, fluctuates sharply in short term. It's a very important factor in profitability. So polymer manufacturing plants are typically located near the pipelines that supply those raw materials. And polymer supply chains are quite regional. Plants serve a certain region. They operate pretty independently. There's not a whole lot of stock transfer going on across region. A typical polymer manufacturer, let's say, would have 3 to 6 plants, 2 to 10 lines per plant, and they try to dedicate a production line to a family where possible, because the requirements to transition from one family to another produce sub-grade off-spec product, and it's a margin hit, not advisable. Number of customers in a region can be anywhere from 250 to greater than 1,000. Customers have multiple ship-to sites, so you're looking at a large, complex distribution network, thousands of customer ship-to locations. And the way product is distributed is also very different by region. When you look at, for example, US is all largely rail car based. When you're looking at Saudi Arabia, for example, it's all based on sea. When you look at Europe, it's all trucks. In India, it's a combination of sea and truck. So the key point I'm trying to make is there's a lot of distribution network complexity and variety. In the lead time to ship product from plants to these forward distribution points is 10 to 14 days. while the lead time to move it from the forward point to customers on an average 2 days. So what's happening is the more days of inventory you're carrying to account for the transit lead time, to account for the manufacturing lead time, because customers are expecting instantaneous delivery, are you looking at high inventory in the chain that needs to be optimized? Let's look at the manufacturing side of polymer. So polymer manufacturing is a hybrid of batch and continuous processing. Polymer manufacturing plants typically very large, capital intensive, costly to operate. And because profit margins are slim, plants typically operate at full capacity. So the operational efficiency, effectiveness, OEE is very important to polymer. You can almost assign dollar values per second for download, downtime, or transition times. And eliminating efficiency, even a small bit, can save millions of dollars. So for example, the cost of shutting a chemical plant down for a day can easily exceed $1 million. And manufacturers typically produce 10 to 30 campaigns in a cycle. And campaigns follow a particular sequence called the production wheel in the industry. And that means, as you can see, either a simple wheel where you make product A, then you need to make B, then C, then D, then E before you can get back to A. So if you're not getting a lot of demand for D, that's okay to skip it or make a small quantity of it. But you can't go from B to making A. You have to make some of C, D, and E. There can also be sub-wheels where from the main wheel you can branch out into sub-wheels, and this sequencing and planning had major role to play because unneeded transitions, because you're doing more campaigns than you need to, transitioning more often than you need to, can result into margin errors. Also, typical campaign may have 5 to 30 different products, end products, while you are looking at 50 to 400 end products. And once you apply packaging on top of end products, the stock keeping units, SKUs, numbers is even greater. So overall, when you're looking at SKUs and locations, it's a large problem to solve. Let's talk about the planning side of things for polymer. Product demands vary quite a bit. They're very price sensitive. So given the high cost of holding inventory, importance of product availability, and overall raw material pricing fluctuations, it's very important for the supply chain manager to be getting accurate forecasts. How much safety stock needs to be held at terminals is also quite a challenge. The calculation of demand forecast and determining the amount of safety stock to be held to drive the production plan are all very important processes for this sector. Especially when production has to be planned to utilize the plant to the max and have as few of transitions as possible. I mean, breaking a production wheel is possible, but it's not desirable. So what you're looking at is a mixed integer linear programming kind of a problem, which needs to solve for optimal distribution plans, optimal inventory levels, optimal production sequences, and it needs to typically maximize profit, although you can configure these models to also simply just minimize costs. And transportation networks have choices in terms of means of transport, and you can have minimum lot size constraints sometimes, and when you are incorporating these minimum lot size constraints, you also have to model the transition material and the reduced margin you get out of transition material, loss of production time that you get because of transition between runs. So here's the case for an IBP solution that can deliver margin optimization for polymer manufacturers. So just to sum it out, it's a very highly competitive environment. From the viewpoint of the polymer customer, polymer manufacturers are easily replaced. And typically the risk is very high. If a customer is replacing a supplier, is typically not coming back to them. Product price, as I said before, is highly dependent on the price trends of crude oil. And the demand for polymers is highly sensitive to price revisions. So pricing is essentially the key marketing instrument for the company. So when price of a crude oil impact changes your raw material costs on a very short notice, those cost changes typically cannot be passed to customers right away. There's a certain time lag involved. And what this does is it shrinks the profit margin. And in extreme cases, for a certain part of your production, the margin may actually even become negative. So possible reaction to the situation, the companies deliberately reduce quantities they're putting into the market, and they can do other things. But in general, the stock that was produced with raw materials at high cost and being sold at relatively low prices, obviously there's a margin hit. So to achieve high profitability for the enterprise, which is how you define supply chain excellence, which ties to the P&L and balance sheet performance, it's very necessary to pay consistent attention to low production costs, high responsiveness to market demand. And what this means is, on one hand, you're having to plan resources efficiently, and on the other hand, you have to forecast market changes, both on your raw material pricing and your finished good demand as much in advance as possible, and incorporate these changes into your plans with minimal latency. This requires a very integrated, very agile, very strong, very balanced, very resilient supply chain. When you look at this state of high complexity, I hope you got an appreciation of how complex the problem is. It takes an integrated business planning system that can sense demand, that can solve for optimal inventory levels, that can develop optimal production and distribution plans, optimal procurement plans, and do all of this not from a fill rate perspective, not from a forecast accuracy perspective, but from a net margin optimization perspective. So that's what we are trying to bring to you today in terms of SAP Integrated Business Planning, especially in response and supply. And I'd like to ask Jay to give you an introduction.
All right, so I've been asked to go over real quickly the supply part of the module in IBP from SAP called Response and Supply. So let's just kind of go through those pieces. And we talked mostly about the optimized half of this, but there's two pieces of this. So what I'm going to do is spend a little bit of time discussing and reviewing what these pieces are. So the first set of bullet points at the very top of the screen, the support of tactical, which we also call time series supply planning in the context of S&OP, consists of two different parts. One is something we call a heuristic, which is an unconstrained analysis of your load against your capabilities or your capacities. And the other is a constrained optimization option, which does, we call it profit-based, you can call it cost-based. It considers both components, which I'll talk about a little bit more later, in coming up with the most optimal, from a cost perspective or profitability perspective, production plan. So with that in mind, the stuff you see beneath, the operational supply planning and response planning, those are both order-based. Another part of the response side of response and supply. We're going to focus only on the supply piece. So looking at the supply side for planning, the heuristic or optimization allows you to decide for yourself how you want the system to work, whether you want to have it give you an unconstrained plan so you can make adjustments to your demand or make manual adjustments to your capacities and manipulate your rough cut capacity plan the way that you want, or you can run the optimizer, which is going to automatically look at all the constraints across your organization and consider all the things that you see listed on the bullet points on the left-hand side. Your sourcing determination for distribution, your bills of material. It considers your inventory targets and allows you to project both shortages and relevant information about inventory in general. And of course, across all of IBP is the ability to use scenarios to play your simulation games and review all and create alternative plans and compare those plans. So the big deal is I can look at it from a heuristic perspective, which simply identifies where my load from my consensus demand number has been translated into load against capacity, and identify those differences to make adjustments or let the system try to solve this particular capacity issues, assuming you have that. So let's look at those a little bit more closely. I think I've talked about all these different pieces of tactical planning. First off is looking at your supply from a graphical perspective, so you can look at key components. Maybe it's a resource view in your dashboards, so you can look at individual resources or your different aspects of your supply chain. I mean, you decide how you want the dashboard to appear to suit your particular needs. And the collaboration tool is also part of it that goes across all of IBP, all the modules, which allows me to use a social media for business style collaboration tool to have the team work together to resolve issues that may come up in matching your supply with your demand. Simulations, of course, again, are the ability to create different scenarios and compare those scenarios. It allows me to look at different models of meeting my demand with my supply, creating supply plans. And ultimately, you're going to wind up creating two things at the end of the process. One is a rough cut capacity plan, which is how I'm going to set my supply, and the other is basically an MPS, master production schedule, to go back into your execution level systems. So those are the outputs from use cases for the supply side of tactical planning. So if we look at this a little bit closer at the optimizer, for example, the whole idea of the optimizer is to produce the product, get the product from beginning of production to an end customer, to minimize the costs based on the different aspects. And you see a list of, in the diagram, different types of costs that are considered. So I can supply customer 1 or customer 2 with material that begins in either plant 1 or plant 2. And so I have different cost elements for every step of the supply chain. And I'm able to, by letting the optimizer look at those cost elements and look at the price for customers, what we're actually selling it for, and determine what's the most optimal or the lowest cost or maximum profit option is when you have a constraint. So it's a mixed interlinear programming model. And those of you that are mathematicians and data scientists will know what all that means. I'm not a mathematician. I just know it's a black box. It does these really complex mathematical calculations. But at the end of the day, what it does is it recommends where to make what product and how much to make. So when we look at constraints, everybody asks, well, what are the constraints? And so we kind of categorize the constraints this way. First off, for hard constraints, it means we've got to meet these constraints regardless. And some of those are, do I have a stock top limit control set? Do I have lot size I need to worry about? Do I have limitations in my resources? And I think we've been talking about polymers, and one of the key resources for polymers oftentimes is storage. And so polymer materials are stored oftentimes in rail cars, which are kind of mobile floating devices, and they may be owned by a production company or they may be leased as needed. So, so those are the types of constraints that are hard constraints that actually have to be satisfied. The soft constraints are things that you want to consider, but may or may not be required to be satisfied. And you see the list of those things as well, from different cost rates, from both direct costs and things like non-delivery costs and transportation costs, and you guys can read all the things that are there just as well. So those are different types of things where if it has a value, it will be considered. If it doesn't have a value, it won't be considered. So those are the things that when the objective function runs, takes into account to give you what is the optimal solution. And this thing called pseudo-hard constraints, or I've even heard it referred to as unconstrained constraints, which is, I thought, a bunch of silly words, but the soft constraints at a very high penalty cost make them more important. So perhaps non-delivery is your driving factor, and so it has a very high penalty cost, and it goes into the calculation and becomes a primary driver for the optimizer to work with. So I think that's pretty much straightforward. What you're seeing in the little picture on the lower right-hand side is just the job that starts off. It tells you what particular supply fulfillment option to choose from, and then which particular scenario you want to run it against. So you have a lot of flexibility and freedom in terms of how you run the optimizer when you're doing different scenarios. So you can create different plans or different alternatives to compare. So that, in a nutshell, is really what the optimizer and the heuristic, for that matter, are designed to do on the supply side of the IBP platform. Since we released IBP for Response and Supply in fall of 2016, we now have 29 companies subscribing to that. Some of those are companies that have used the product prior to Response and Supply being licensed, but they're not all, some are running the heuristic, some are running the heuristic and the optimizer, some are running just the optimizer, so it's a big combination of all of them. And I kind of broke it out by industry so you kind of see what the mix is, and you'll see that it's all across a the board here. From a consumer products perspective, and I combined CPG and consumer process, like the dairy industry, for example, or a wine producer, which is a process industry, into the consumer products category. So there's 7 of those currently, the 29. Industrial manufacturing or hard goods manufacture, 7 of those. Of the oil and gas and chemical companies, 2 of those are polymer-based companies, actually. So they have been on the leading edge, actually, of trying to use the product. And in high tech, we have a number, and you guys can read what all is left there. So those are the customer adoption for this product since its formal release in 2016. Now, we have more companies using the optimizer because they happen to have been subscribers to IBP prior to it being separated out into its own module. I did not include those in this particular graphic. So the customer list is actually larger for the supply capabilities than is on this list. So that takes me to the end of my part of the presentation, I guess.
All right, that was very useful, Jade. Let's just move on. What I'd like to do is give folks a response and supply showcase.
Hello everyone, this is Ashish Meshram. I am working as a lead IBP managing consultant with GitaCloud. I worked on various customer POCs, and it's my pleasure to take all of you through the IBP showcase. So in the next, let me take you to the context of this showcase. So in the next 15 to 20 minutes, we'll be seeing what IBP supply planning capability has to offer to you and to your organization and to the business. So basically here we are going to look into two all algorithms, and we are going to compare the results of these 2 algorithms. So the first one being the heuristic, so which is a unconstrained demand and supply planning. It's a rule-based planning, so wherein it is considered the resource capabilities are not taken into account, and it is assumed that the resource capacities are infinite. And the next one being the optimizer, which is a cost-based algorithm, wherein it takes into consideration the various costs that is involved into your production, your transportation and inventory, and it provides the optimal solution based upon the cost parameter that we have maintained. Okay, so this is the supply chain network that we are going to model in our demo that I'm going to present with you. So in this supply network, we have a customer which is being supplied by 2 distribution centers, that is warehouses, and these 2 warehouses are being supplied by the production plant, 2 different production plants, which in turn procures its raw material or component from an external vendor. So before beginning, so let me show you the important master data that we need to take into consideration before running our supply planning. So I'll directly move to the Excel part, wherein I will showcase the actual planning. So let me show you let us review the master data that is required for our supply planning. So we'll look at the master data for both the algorithm, that is our rule-based heuristic, and cost-based optimizer. So we need to there are some prerequisite and the compulsory master data that needs to be maintained for both the algorithm. We'll look both of them one by one. So currently we'll be reviewing master data for heuristic. So there is something called sourcing ratio in heuristic that we need to maintain. The sourcing ratio basically defined how a demand for a customer or at a certain location has to be satisfied. So IBP distinguishes sourcing rules for customer demand by the name customer ratio, for transportation as a transportation ratio, and for production as the production ratio, and unspecified sources. So I'll show you the sourcing ratio that we are going to follow for this particular demo. So this screen shows the sourcing ratio that we have maintained for our network. So first is our customer sourcing ratio. So customer sourcing ratio defines from which location, it may be a distribution center, plant, or a supplier of your supply network, a customer demand needs to be satisfied, and in what percentage. So if you can see in this screen, for customer 1000, so it is being supplied by 2 DCs and a plant in a certain ratio. It's 50% from DC to 400, 30% from 2500, and that's 20% from the production plant. If you see in the Excel sheet, we have a master data workbook wherein we need to maintain all these entries. We have a customer location product, and you maintain the customer sourcing ratio that you want to maintain for your customer and the locations. So next is your location source. So to plan your supply through your stock transfer from one location to another, you need to specify a suitable transport sourcing ratio. So basically, in order to supply from one location to another, you need to maintain a transportation ratio, which here we call as a location source. This enables you to show your transportation facility between your locations. So here we specify which production plant is giving to which particular DC, and what is the quota that it is using to fulfill the demand for that particular location. So next is your production source. So it is a way to satisfy the demand that we need to manufacture at our plant. So basically, it shows what is the ratio that you need to produce of that particular finished good at your respective production plant. So these are some of the prerequisite master data that you need to maintain for your heuristic in order to have a proper heuristic run. So if you look at this, we have a product and the customer, and we are entering demand for these two product at this particular customer. So now I'll take an heuristic run. So we can run supply planning operator from the IBP ribbon as shown. And also we can check the status of our planning run. Since the job is finished, so as you can see, the job is finished. I'll just refresh to see the view. So once your job is finished, we need to check all the receipt key figures, and that is the plan that the algorithm has suggested. So as you can see this particular screen, so it just showed the customer demand. It is being fulfilled from which location. So if you see, if you remember, we have maintained customer sourcing ratio. So the heuristics generates the plan considering that ratio, and it gives this supply as per the ratio maintained to all of the locations. So this is the customer view. Let me show you the transportation view, wherein we are wherein the plant is supplying to the DCs. So in the next screen, the plan to DC transport view, you can see the my ship from and ship to location. So basically here the plant is supplying to the DCs, and we have maintained the ratio, the transport ratio in our master data. So when this rule-based heuristic generates a supply, it takes into consideration that ratio and then accordingly generate the plan. So next we'll look into the capacity view. As you know, heuristic is an unconstrained supply planning algorithm wherein it takes into consideration that it has infinite capacity. So you can see here the capacity is more than 100%. I mean, it is giving 230 or more than 100% wherever required. So it is assuming that it doesn't have any resource constraint and it is of infinite capacity, and it produces the result accordingly. Also, we can create a multi-level bomb within the supply planning heuristic, and accordingly, when you run your algorithm, all your dependent demand will go downstream to your bomb level, and those are the setting that we need to maintain in our in the master data setup before running the algorithm. So the next algorithm we'll be looking at is the optimizer, so which is a cost-based algorithm. There are certain parameters that we need to take into consideration before running optimizer algorithm. So this is some of the required settings that we need to maintain in order to have a cost-based optimum result from the optimizer. There is a global parameter, optimizer parameter, that we define in the configuration in the web UI. So there are certain cost factors: the global cost factor, the penalty cost, and the mode. So in IBP, optimizer runs in two modes. One is your profit maximization, second is your delivery maximization. So yeah, you can run on either of these mode. And also, if you can see in my screens, so this is the optimizer profile that we are maintaining in the configuration. We maintain all the cost factors, the penalty cost associated with the different cost rates. We maintain mode and also the fair share distribution. So this is the standard optimization profile that we are using, but in our master data, if we are maintaining any data, any cost related key figures in our master data, then this optimizer profile is gets overwritten by what we are maintaining in our Excel sheet. So that that is something we call as a time dependent and time independent setting. So in every master data, you have something called a time series indicator. Basically, it's a time dependent and time independent. So if you enable time independent, so it will take the values whatever you have maintained in your key figures. So here for this demo purpose, we are maintaining the production cost rate, and the inventory holding cost rate, and the non-delivery cost rate as a key figure. So here we have maintained a production cost rate for our products at the location. This is the necessary setting that we need to do in order to have a optimal result from the optimizer algorithm. So next we can see the inventory holding cost that we have maintained. So once all the cost parameters and the cost related key figures are maintained, we run the algorithm. So let me run the optimizer. We can check the status and the log of optimizer run from the status field and the IBP ribbon. So you can check the solution information from the log that is generated once your job is finished. So now let us review the planning result that is being generated by the optimizer. Since, as I mentioned, the optimizer is based upon the cost that we maintain, so it doesn't take into consideration the sourcing rule and the location sourcing rule that we have maintained in the master data as part of our heuristic run. So it will not take that into consideration. It will just take into consideration the cost that is being associated with that product and the location. And since it is a finite planning, it will consider that it has a finite resources and the capacity of that resource is also finite. So it will try to minimize the load or the overload that we have generated from the heuristic run. So this is the result we got from the heuristic run. So if we check the optimization result with respect to the capacity, so we can see the result suggested by optimizer will never exceed 100%. It will always try to share the load of the resources optimally based upon the cost parameter that we have maintained. So this is how the optimizer is producing a constraint result based upon the cost parameter that we have maintained. So what we can do from here is we can compare both the heuristic and the optimization result, and basically this shows the capability of IBP, what it has to offer in terms of both the rule-based algorithm and the cost-based algorithm. So there is one more very intuitive feature in IBP wherein we can see this the result what we are seeing in Excel in terms of the dashboard, in terms of the charts and the pictures. So if you look at the dashboard, we can create any kind of dashboard. The IBP offers all the latest charts, bar graph, and network design charts to showcase the result that has been produced by any algorithm. So here, for the sake of comparison, we can see we can create various graphs and the charts and can see the comparison between the rule-based algorithm and the cost-based algorithm. You can see the production capabilities and the utilization. So it gives you a visual treat, and it gives a better visibility on the situation on the hand. With this, I'll just before concluding, I'll just want to recap what all we saw today. So we started with the aim of this demo is to showcase the functionality of IBP supply planning in terms of two algorithms, rule-based and the cost-based, heuristic and between optimizer. So we saw one network design, we saw the necessary master data we need to maintain for your heuristic, the necessary cost parameter that we need to maintain for your optimizer in order to have optimal result. We saw the dashboard, we saw the comparison of the result between the heuristic and the optimizer. And also this is something standard, but this can be custom as per the business requirement. You can add your financial key figures in order to compare your revenues and the various cost that is being associated with the different business processes. So you can very well add different custom key figures on top of the standard key figures that are available. I will be happy to help you and answer your queries at any point of time regarding the demos, maybe in the workshop or into one-to-one interaction. So thank you all. Hope you understand this demo. Guru, back to you.
We are ready to launch into the wrap-up section of the presentation. What I'd like to quickly talk about is we have, for folks that are not familiar with this program, we do IBP workshops throughout the year, focused on all the IBP applications across response and supply. That one is coming up on July 29th this weekend. These are 4-day classes. 2 weekends is what you're looking at, so July 29th, 30th, and August 5th and 6th. And we take learners through a very deep hands-on dive into the system supported by the GitaCloud team. We also have another one coming up on sales and operations planning on August 19th, and demand and inventory workshop is coming up in September 16th timeframe. You can go to gitacloud.com/products if you want to learn more. With that, I think we are ready to launch into the questions. So Puru, back to you.
Okay, thank you. So thank you all for your attention through the content section of the webinar. We are ready for the questions. This is the reminder to all attendees that you can type in your question in the chat section of the GoToWebinar control panel. We already have a few questions up here. So let me start by picking some of them up right now. Okay, the first one is, how does IBP Supply Optimizer differ from APO SNP Optimizer? Ashutosh, do you want to take it?
Yeah, sure. I'd like Jay to take first cut at it. Jay?
Okay, so the fundamental calculations in the APO SNP Optimizer and the IBP Optimizer are the same. The IBP Optimizer was based on the SNP Optimizer. So they're very similar. Again, as I mentioned before, I'm not a detailed mathematician, so I can't tell you the exact differences, but they're the same basic foundation.
Okay, thank you, Jay. Next one is, how much does it cost for response and supply? Is it like remote or on-site? Some question related to logistics about the software. So Ashutosh, do you want to take it up?
It is a cloud software. It's only available in the cloud. If the question was around pricing, we would like to take that one offline, have the person reach out to me on an email. I'll project that towards the end. We can take that one.
Okay. Is there log information after the optimization run to check which constraints are being satisfied to make a decision on the results?
Yeah, so I probably need to take that one then. So yes, there is a log. I'm not sure how clear it actually is to say which ones are satisfied, but if you're running the optimizer, it's going to satisfy all the hard constraints and probably all the soft. It's going to solve all the constraints regardless how you define them. Go ahead.
Sorry, go on, Jay.
I was just going to say how we categorize between the pseudo hard and the soft really is just to what degree of intensity those particular constraints are. So go ahead, Ash.
Thank you, Jay. And yeah, just from a roadmap perspective, in the next release, you will also see more enhanced, more friendly functionality in terms of IBP Supply Optimizer logs, where when things are not satisfied, it will actually tell you what the constraining factor was. Was it lack of capacity? Was it lack of raw material availability, and so on? So this was one of the pain points with the APO Optimizer application, when people were not able to fully understand some of the decisions Optimizer had taken, and SAP is taking all the right steps to make sure this is a very business friendly product and solution that we are talking about. So along with the high-grade math optimization, it's also focused on making sure it's intuitive to the planner. Okay.
Let's take up the next one. How does IBP Supply Optimizer work with Inventory Optimizer? Do they run sequentially or do they run in a single solve?
No, they run
Okay.
sequentially. Yeah, they run sequentially. You would run your inventory optimizer first to determine what your safety stock and target inventory levels are, and then that becomes a part of the calculation for your supply optimizer. So they run sequentially.
Okay. Do the optimizer and heuristic sync real time with SAP ECC, and like the next one is how is the data flow actually managed in real projects?
Okay, so IBP is a standalone system, so all data in and out of the system is done through an ETL process when we're talking about the optimizers. So the degree of frequency is up to the individual user. You can run the ETL process every hour, every 5 minutes if you want, or once a day, whatever makes the most sense for your business. But it is not they're not real-time linked. There is a ETL process between the two.
Okay. The next one is SAP providing support for supply plan collaboration with contract manufacturers through Ariba? If not, is this on the roadmap?
It is that we are providing support for this. It is actually, I think we had our first component of the integration with Ariba in the 1705 release, which was last May. We will continue to enhance that in the release coming up in August and November. So the first part, of course, is the requirements to the supplier and the commits back from the supplier being fed into IBP. We're going to take it to the next, we're actually doing projects to take it to the next level, where we're going to be looking at inventory at the supplier, and then the inventory at the supplier, of course, assuming they're all in the Ariba network.
Okay. A side question is IBP Optimizer available as a part of IBP SNOP application, or one needs to buy IBP supply separately? Ashish?
Yeah, no, I think it is part of IBP response and supply. IBP SNOP, I think, has supply heuristic, not optimizer.
Correct.
Okay. Can IBP Supply Optimizer run across mid-long-term horizon or as well as short-term horizon, or does SAP recommend to run supply heuristic for rough cut capacity planning?
The IBP platform itself is designed for the mid to long-term planning horizon. It is an extension of the SNOP process, which is its core foundation, and that by definition is mid to long-term planning. So the answer is yes to all. It can run for whatever time horizon you wish, but keep in mind it is a time series based solution.
How are the planning results being taken back for execution? There's a question about the system integration. Jay?
Yeah, so as I mentioned before, all data transfers in and out of IBP are done through an ETL style process. So the process of coming up with your plan, your rough cut capacity plan, and your MPS is done in IBP, and then that is extracted back once approved to your ECC system or whatever your system of execution is.
Okay. Is SAP providing support for supply plan collaboration with contract manufacturers? Okay, we've already covered that, I guess.
Yep.
I think we're mostly
Yeah,
done
I
with
see
the
a question
questions.
here. The 29 customers that you showed, are those in North America only, or that's a global number?
No, that's a global number.
Okay, all right. So I think at this point we probably have answered most of the questions, and for some of the other questions we are a little bit out of time, so we will follow up with people one-on-one after this webinar.
This is all the time that we have today. We will shortly upload the recording of this webinar on our website, maybe tomorrow. Thank you all for your time, and we look forward to your presence in the next webinar of the series, and especially the workshops coming ahead. Thank you.